Hi, it's Kiffin Bates here, and today's video is a Ledger 101 video. Now, to some of you this is going to seem blindingly obvious and trivial, but to others it might be quite eye-opening. And in particular, I'm going to look at the confusion or the disconnect that is created by the language that we use to describe transactions and how those transactions are actually implemented in a ledger manner in cryptocurrencies. So to start off with, let's look at the language that might be used to describe a transaction. My wife says to me, pay our daughter her pocket money this week. And I take a 10 euro note out of my wallet and I give it to my daughter, and now she has it. So there we have a physical object, a 10 euro note, that is in the space that I control, namely my wallet in my pocket. And at the end of the transaction, the 10 euro note has been physically transferred through space into an area controlled by my daughter, in this case her hand. And we call that a transaction. Now with a ledger, we use the same terminology, but a different process is happening. And you can, at its simplest, think of a ledger as a two-column list, with the first column being names and the second column being numbers representing balances. And let's say that instead of using physical cash, my household used a ledger system to record pocket money events. So I could have a whiteboard in my living room, and we could have the names of all the members of the household written down in the first column, and we could have the balances that everybody has written in the second column. And against my name there might be a balance of 1,000, and my daughter will have a balance of 0 because she spends all her pocket money immediately on candy and soft drinks. So when my wife says give our daughter her 10 euros pocket money, what I will do is I will rub out the 1,000 against my name and write down 990, and I'll rub out the 0 against my daughter's name and I'll write down 10. And we use the same language to describe what has happened there in terms of a transaction. I've given my daughter 10 euros, except underneath everything, that isn't what has happened. There have been two separate events, my balance being deleted and rewritten with a 10 subtracted from it, and my daughter's balance being deleted and rewritten with 10 added to it. And so as an outsider looking at that, you may make a conclusion that a transfer of 10 euros from me to her has happened, but from a mechanical point of view, that's not the case. There just happened to have been two events that happened at roughly the same time, and the meaning that a transfer has happened is something that the human mind puts onto that. The system itself is just meant to be set up so that there's conservation of total sum of balances. So it's like the equivalent of the conservation of mass in the universe. And in order to know that that change in balances on the ledger was actually a transaction between me and my daughter, we'd have to write down a separate second entry somewhere. Maybe there'd be a second whiteboard, and we write down date transfer from me to her 10 euros. And we can keep a record then of all the transactions that happened, and we use the ledger to actually know the state of our financial universe in our household in that time. So this is where the disconnect happens. The fact that the meaning that we put on ledger transactions is different from what is actually going on underneath. And this transfers across to cryptocurrencies, because if you look at ERC20 tokens on, for example, the Ethereum blockchain, ERC20 balances are kept track of in something called a mapping, which is basically the equivalent of that two-column list that I described when I was giving the example of using a ledger to keep track of household balances. And the fact that a transaction has happened, that a certain sum or a certain amount of an ERC20 token has been transferred from one address to another, the fact that it's a transaction is kept track of through something known as an event. These things are, in quotes, emitted onto the blockchain. So it basically means that you have a ledger in the form of a mapping in a contract, and then you have these events that are recorded on the blockchain to say, well, this is why the balance changed, this is what happened to cause that. And then you interpret those events in order to understand the meaning behind it. And you see this in, for example, non-fungible token contracts like ERC721 and ERC1155 contracts, in that the contract has a record of who owns which NFT, and then the events tell you what the meaning behind any particular transaction was. So, for example, if you see an event on the blockchain that says an NFT was transferred from the 0 address to a given address, that is interpreted as a minting event, because the 0 address can't actually own anything. It's not really an entity as such. It means that something came into existence. Similarly, if you see a transaction where an NFT, so let's wait for this rubbish truck to go past. If you see a transaction where an NFT is transferred from an address to the 0 address, this is interpreted as a burning event, that the NFT has been destroyed. And finally, if you see a transaction event where an NFT has been transferred from one address to another address, well, that is interpreted as a standard transaction where I am giving you an NFT. And there are some problems with making these interpretations. Firstly, other than the specification saying that you should produce these records of transactions, there's no obligation for your contract to actually do that. It'll function perfectly well if you just implement the ledger part and don't implement the record part where you keep track of the meaning of changes in the ledger. So you can create an ERC20-like contract or an ERC721-like contract, but skip all the event emissions. And what will happen then is that certain websites like OpenSea won't be able to pick up on the fact that transactions occurred, but the balances are still recorded. So you can still go onto the blockchain and query whether or not you own a particular NFT or how much of an ERC20 token you own, and you'll get a sensible answer back. So I think I should probably start wrapping this up because it's been going on for quite some time. But this is the key thing to remember. We use language to describe transactions, and we use the analogy of physical transactions, of transference of property, but that's not what is happening in a ledger system. And secondly, in order to make the ledger make sense over time, we often keep separate records to try and track what the meaning of particular changes in balances on the ledger actually mean. And if you start playing around with these things, you can end up with contracts that on the surface look like they are going to function in a normal, understandable manner, but you can pull all sorts of tricks. And that will be the topic of a video that I will be releasing shortly. So keep an eye out for that. That's the conclusion of Ledgers 101 in cryptocurrencies and NFTs. Hope you found it interesting, and I'll see you in the next video soon. Bye for now.